Now we'll look at domain and range. The domain of a relation is the set of all possible values which can be used for the input or the independent variable. These are all my x values. And then we have the range of a relation, and that's the set of all the possible values of the output or the dependent variable, usually denoted as y. So let's look at class example number 1. We're going to list the domain and range of the following set of ordered pairs. Now remember, if I'm listing the domain, then that's just the set of x values. So first of all, I'm going to be listing my domain for these values. Now, if we're naming a list for the domain, then we use these special pointed brackets. And we start with the lowest value of my x, my domains. So I got 1. So all these first numbers are x values. My lowest one is -3, and so that's the one that would go first. And then I would start listing my numbers in ascending order. So next I have 0. Then I have +1. Then I have 3. And then I have 5. So that's my domain as a list: -3, 0, 1, 3, and 5. Next is my range, and remember the range is the set of y values. So I would do the same thing, make another list. However, this time I would list my y values. Now, if you look, I have my lowest y value, which is 2, but I also have another 2 over here. Now, I don't have to list it twice, I can list it once. Next, I have 5. Then I have 8. And lastly, I have my 9. We're gonna name our domain and range for each of these graphs, so A, B, and C. So first of all, my domain. Now here I'm given some discrete data. Right? With discrete data, I can't just say my graph includes all the values from -3 all the way to +5. I have to make sure that I list only the values that are included if we have discrete data given to us. So the first value I have here, and again, I'm going to start with my lowest value here. So my lowest value is -3. And then I increase in ascending order. So I go -3, -2, -1, 0. -3, -2, and I go all the way to +5. -3, -1, 0, 1, 2, 3, and I'm going to start cutting into my other question here, 5. So that's my domain. My range, remember, is the set of all my y values. So it starts at 0, and it goes all the way up to 1, 2, 3, 4. So 0, 1, 2, 3, 4. This gives us a better idea as to why we don't list the values that turn up twice. So for example, I had a coordinate here at -2 and +1, and I also have a coordinate here at 4 and +1. So listing it twice in the range is kind of superfluous, because it's, if we list it once, that's okay, and that just shows us where I have data points in my y values. Next, we'll look at example B. Now with example B, this data is a little bit more continuous. However, there's a point at 5 that's not included in this data. So the way we would list this is a little bit differently. And the way I'm gonna list it here is like this. I'm gonna first look at my domain. I'm gonna write it down here. And the way I'm going to list my domain is I'm going to talk about my x values, and I'm going to say my x values, and this straight line here just means such that. Now, here I have an actual range that my x values can be. my x values can be located at -3. So -3 is going to be the lowest value that my x value can have. So -3, and it includes that value. So x has to be greater than or equal to -3, but it has to be less than +5. See how this +5 is not an actual value? I don't have an x that can be +5, and so it's just less than, not equal to 5. And then I can close this bracket, and I could also say that x is an element of real numbers here. And then I would do the same thing for 5, for my range. So my range, I'm going to list this as, so my y values, such that, now this one's going to be a little bit trickier. Now, even though 0 is a value here, it's not a value here. And so that's actually going to be another place where we can't have our range. So we're going to say that x has to be greater than 0, but it has to be less than or equal to +4. And again, y is an element of real numbers. Now with this last example, I have my domain. And again, we're talking about the x values here. So with the x values, all real numbers, I'm just going to say x is an element of real numbers. This goes infinitely. That's what these arrows mean, is this graph keeps extending infinitely. So x is an element of real numbers. When we write it like this, that just means any number of x is going to work on our graph. For our range, however, the highest number is 4. And so I'd say that my range of y, y has to be less than or equal to 4. And y is also an element of real numbers. So it's continuous below 4, but our graph doesn't go anywhere above 4. Now let's say the domain and range for these graphs here. And I'm just going to do, I'll do these three graphs. So now we're going to state the domain and the range of the following relations. So first of all, my domain can also just be expressed as D, but range also just be expressed as R. First of all, this is a continuous graph extending and including all my values on my horizontal axis, on my x-axis. So we could say that x is an element of real numbers. My range, however, starts here at -3. And so we're going to say that y such that y is greater than or equal to -3. And we'll say that y is also an element of real numbers. For my domain in part B here, my lowest value looks like it's at -2, where my highest value is at +4. And those are t values in this case. So we're going to say that the elements of t such that t has to be greater than or equal to -2, but less than or equal to +4. And t is an element of real numbers. And then we'll close that bracket. And for our range, we'll take the same approach, but again, we're looking at the vertical axis now. Looks like I'm at +1 and -3 here. And these are p values. And so we're going to say that p such that p has to be greater than or equal to -3, but less than or equal to +1. So that's the lowest point of my graph and the highest point of my graph. And p is also an element of real numbers. With this example, I'm going to list my domain and range again. And we're just going to make a list. So these are my, if you have values that are listed like this, these ones are going to be your x values or your independent variables, and these ones are going to be your y values or your dependent variables. That's just the way they set this up. So these are being mapped to certain points. So these are our output values, and these are our input values. So we're just going to make a list here, 1, 2, 3 for my domain, and 2 and 6 for my range. So in class example number 5, we're going to look at a high school football team is hosting a banquet to celebrate winning the championship. The caterer charges a setup fee of $500 plus $20 per person. And then the equation that represents the cost of hosting the banquet for n number of people is given as C, or cost, is equal to 500 plus 20n. We want to make a table of values with 8 entries for a minimum of 100. So n would equal 100, that's our minimum, and our maximum number of people is 500. So first of all, the cost for hosting 100 people, if we plug this into our equation, C is equal to 500 plus 20 times 100. C would equal 2,500. And 10,500. So here's our table of values, and what we're now going to do is plot these ordered pairs in our graph below. All right, so that's the grid we're going to use, and now we're going to place our ordered pairs. So 100, 2,500, it's right here. Here we have our ordered pairs. Now that we have our ordered pairs plotted on our graph, we can put in a line, and a line here makes sense as long as we don't start from 0. Right, because we had our minimum amount, which was 100 people, and our maximum amount, which was 500 people. And I should probably include my minimum amounts on there. There we go. And let's just pretend it doesn't go past that point. And now, if all possible ordered pairs from B were plotted on the grid, we want to state the domain and range of the relation and explain why there are restrictions on both. So first of all, my domain, if we're talking about the variable n, the number of people, such that 100, as long as n is greater than or equal to 100, but less than or equal to 500, such that n is an element of natural numbers this time. So remember, if you jump back to the beginning, our natural numbers, those are the numbers from 1, 2, 3, 4. They're infinite, but they also don't include numbers like 0. They don't include negative values. Our range, with our range, we can just make our range as a list of all the values in between, and if we can talk specifically about the values that we actually gave. So 25, 45. And then so on and so forth, all the way up to 10,500. Now there's going to end up being restrictions, so values that it can't equal, because the number of people has to be a natural number, right? We can't have half of a person present at this event, and so that's another reason why we have natural numbers here instead. So even though I drew a line showing there is continuous data in between these points, we can't have like 100.1 as an example. We can't have 100.1 people at this event. So there are going to be some restrictions because of that.